Now, let me show you. I have here a circuit with 2 volts, and if I measure the voltage across the battery, what I get is almost 12 volts, 11.86. Now, if I measure the voltage across that top bulb, it's almost 6. Okay, so it should be 12 volts, 6 volts, and 6 volts. Now, if I unscrew this bulb, the voltage across the dark bulb is 0. And sure enough, that's what I get, 0 volts. Any path from one side of the battery to the other has to add up to 12. And so that means that the 12 must be across that that empty socket. Okay? Now, some of you, I know what you're thinking. You're thinking, oh, well, when you hooked up the voltmeter, you completed the circuit, and that's when there was 12 volts there. But, you know, if you'd have left that voltmeter home, or at least in the other room, there would be no volts there. Let me see if I can convince you. If I have a simple circuit with a 12 volt battery and 3 resistors in series, and let's say that those resistors are all equivalent. Let's say they're 10 ohms. 10 ohms, 10 ohms. Well, if this is a 12 volt battery, then each of these is going to get the same share of the 12 volts, and it would be 4 volts, 4 volts, 4 volts. And I would have a fairly big current through that circuit. Now, if I replaced this middle resistor with a much bigger resistor, say 10 million ohms, well, now this current through the whole circuit is going to reduce to a trickle, and by V equals IR, the voltage across these resistors are going to be 0.0000001 and 0.000000001, and that means the voltage across here is going to be 11.999998. Since this represents almost all of the resistance in the circuit, it gets almost all of the volts of the battery. Now, if I increase that resistance even more by taking the resistor out and leaving the gaping hole behind, essentially making that resistance infinite, well, now the current through the circuit goes to 0. By V equals IR, this gives 0 volts. This gets 0 volts, and that means here I've got to have the full 12 volts of the battery. And that 12 volts is there whether the voltmeter is in the room or not. Remember, I taught you that it takes about 30,000 volts to throw a spark across 1 centimeter of dry air. Well, if I make this gap here 1 centimeter, and I turn this battery into a stronger battery, let's say I've got a dial that I can twist and make it stronger and stronger and stronger. When I get that up to 30,000 volts, I'm going to throw a spark across that gap. The pressure difference is what I mean when I'm talking about voltage. It's the voltage difference or electric pressure difference from this side of the gap to that side of the gap. When that voltage difference gets big enough, it can actually throw current, the spark, through that gap. Okay, you're never going to see that with a 12 volt battery. But with a 30,000 volt battery, you buy those at Costco, they cost only $8 million. Okay, you can get that to happen. Now, the key is contained in one single word. When we were talking about the voltage model, it turned out to be very simple. What goes up must come down. The 12 volt rise across the battery had to be matched by a 12 volt drop around any loop from one side of the battery to the other. I never said any closed loop, any loop. I have to have a 12 volt drop.